So in the last lecture we discussed comparison result, and it says that if you have two positive sequences, an is non-negative and bn is also non-negative, and if you know that an is less than or equal to bn, then you can make these claims. The claims are this: if summation bn is convergent, it means that the bigger summation is finite. Okay, then the smaller summation is going to be finite. And the other statement we can make here is if the smaller one is infinite, then the bigger summation is also infinite. Is my voice clear, or are you getting any breaks?
Clear.
So if summation an is divergent, then summation bn is going to be divergent. It means if the smaller sum is infinite, then the bigger sum is also infinite. So I think we did some problems on these comparison results. Like initially itself you need to decide whether the summation is convergent or divergent. So accordingly you can choose bn or an and you can decide. Or at least you must be able to decide what is the bn needs to be chosen. So now, okay, and you may have some question. What if, like, sometimes it may be difficult to find the sequence that can be compared with given sequence, right? So in that case, the better thing is we have a beautiful result that is called limit comparison result. Okay, you just tell me one thing. If you know that an equal to a constant times bn, okay, then what can you say about summation an and summation bn? ఇక్కడ యాక్చువల్గా ఏంటంటే an ఈక్వల్ టు l ఇంటూ bn అని ఇచ్చారు సార్. సో ఇచ్చినప్పుడు ఈ సమ్మేషన్ an సమ్మేషన్ bn గురించి మనం ఏం చెప్పొచ్చు అంటే ఒకవేళ an కన్వర్జ్ అయింది అనుకోండి సమ్మేషన్ an సమ్మేషన్ bn ఏమవ్వచ్చు?
సార్
కన్వర్జెంట్ సార్.
కంపారిజన్ టెస్ట్ లో బిఎన్ ఎలా ఫైండ్ చేయాలి సార్?
కంపారిజన్ టెస్ట్ ఎట్లా ఫైండ్ అవుట్ చేయాలా?
అవును సార్.
ఒకసారి నేను చెప్పిన లెక్చర్ ఒకసారి రివైజ్ చేయండి మీరు. నేను అక్కడ ఎండ్ లార్జ్ అయినప్పుడు యూ నెగ్లెక్ట్ ద స్మాలర్ పవర్స్ అండ్ యూ టేక్ కన్సిడర్ ఓన్లీ హయ్యర్ పవర్స్. ఓకే, అంటే ఇప్పుడు n పవర్ 4 ప్లస్ n క్యూబ్ ప్లస్ n స్క్వేర్ ఉందనుకోండి, దీన్ని జస్ట్ n పవర్ 4 కింద ట్రీట్ చేయండి. ఎందుకంటే n లార్జ్ అయినప్పుడు దిస్ ఎంటైర్ క్వాంటిటీ విల్ బి ఈక్వల్ టు n పవర్ 4. ఓకే
ఓకే సార్.
ఒకసారి ఆ లెక్చర్ మీరు రివైజ్ చేయండి, ఆల్రెడీ యూట్యూబ్ లో పెట్టాను కదా. సో స్టిల్ మీకు అది క్లియర్ కాలేదు అంటే నేను అది డిస్కస్. యా, ఇప్పుడు సీక్వెన్స్ an అనేది కాన్స్టెంట్ మల్టిపుల్ ఆఫ్ bn అయితే, సో యాక్చువల్లీ ఈ సమ్మేషన్ an సమ్మేషన్ bn రెండింటికి సేమ్ బిహేవియర్ ఉంటుంది. అంటే ఒకవేళ కన్వర్జ్ అయితే రెండు కన్వర్జ్ అవుతాయి. సో ఇఫ్ వీ హ్యావ్ ది సిచ్యువేషన్ దెన్ both summation an summation bn behaves the same. Behaves the same, I mean అయితే రెండు డైవర్జ్ అవుతాయి, either both converge or diverge. అంటే ఒకటి కన్వర్జ్ అయ్యి ఒకటి డైవర్జ్ అవడం అలాంటివి ఉండవు ఇట్లా. ఇలా ఒకవేళ సీక్వెన్స్ అనేది ఇంకొక సీక్వెన్స్ కి కాన్స్టెంట్ మల్టిపుల్ అయితే. ఓకే, సో ఇప్పుడు ఏం చేస్తామంటే బేసికల్ గా యాజ్ n goes to infinite, we want to see the relation between two sequence an and bn. Okay, and suppose if as n goes to infinite, if you came to know that an is almost like a constant multiple of bn, అంటే ఇట్లా అవ్వాలంటే ఏమవ్వాలి సార్? This implies this an over bn must be equal to L as n goes to infinite. The same expression we can write it like this. Limit n goes to infinite, an over bn, that must be equal to L. Okay, and this L must be non-zero, because if it is zero, it doesn't make sense. Okay, so I'm taking L to be non-zero, of course. So suppose if you observe that as limit n goes to infinite, an over bn goes to L, then we can conclude that the summation an and summation bn will have the same behavior. Okay, if you are actually struggling with the comparison result in finding bn, okay, this limit comparison result will help you in finding bn so easily. Okay, uh, so here you can see that, I mean, whatever I stated here, this is what the limit comparison result. Limit n goes to infinite, an over bn, if it is equals to L, then both summation an and summation bn will have the same behavior. Okay, so I'll pick up one problem here. Yeah, I hope you can see the statement of the limit comparison result. You just see up to here. The below I'll discuss it later after some time. Can you see the statement here? So limit comparison test. It states that let an and bn, summation an and summation bn be series, and here an and bn are non-negative. Okay, strictly positive. Okay, at least they have to be positive after some stage. It's not needed that from the beginning they need to be positive. Even after some stage, if they are positive, then that is fine. Okay. And you take the limit of so if you look at the statement, it says that if limit of an over bn is a constant, which is strictly positive, then summation an and summation bn both converge or both diverge. And octocla is a behavior. Okay, so let's try to take some problem here. Yeah. So let's take this problem. So first, what you do is you better write nth term for this. What would be the nth term? If so, an equal to, it's 1 plus ln of, okay, then I need to see this pattern, which is actually 4, 9, 256. It seems like this is 2 square and this is 3 square, yeah, and but it's not 4 square, right? See, there's a typo here. It is supposed to be 27, not 9. So that's why it is 3 cube. Okay, so the pattern is of the form n power n. Okay, so how about this one? 9, 14. What is the pattern you can guess there?
And n square plus 5, sir.
N square plus 5. So that's going to be n square plus 5. Okay, so therefore an can be rewritten like this. An equals to 1 plus n times of ln n. Okay, so over you get n square plus 5. But I hope this is the problem which is going to be divergent. Alright, you keep this here because I did discuss the divergence case in limit comparison test. So I'll move to some other problem. I'll come back to this problem again. So okay, I wanted you to try this problem using limit comparison test. Summation sine of 1 by n. What do you think? Is it convergent or divergent? Let me help you here. So we have sine 1 by n, right? And you know that when x is very very small, it means if it is close to 0, sine x is same as x. So similarly, I can actually see the sine of 1 by n is same as 1 by n. So we can feel like this is summation 1 by n. Okay. So if you want to apply limit comparison test, you just do one thing. You take an equal to the given series term, and you take bn equals to 1 by n. Now what I'm going to do is limit n goes to infinite. I want to take an over bn. So that's what limit n goes to infinite. We're going to get the sine of 1 by n, yeah, by 1 by n. Okay. So let's do one thing. Let's try to substitute x equals to 1 by n. If I take x equals to 1 by n, then as n goes to infinite, what happens to x? X goes to, it's like 1 by infinite, it goes to 0. So if we rewrite this integral, sorry, limit, that is limit x goes to 0, because n goes to infinite, it means x goes to 0. I want to write everything in terms of x. So this is sine of x over x. And this is nothing but, now I hope you can see 0 by 0 form. You can apply L'Hospital. So this is limit. So limit x goes to 0. You will get cos of x over 1. So that's nothing but cos of 0. And what do we get? This is 1. So the final observation here is limit n goes to infinite, an over bn, that equals to 1. Okay. Therefore, by limit comparison test, we know that both an, summation an and summation bn will have the same behavior. So we got the limit of an over bn as n goes to infinite 1. Okay. So by comparison test, both have the similar behavior. So first, let me think about summation bn. What is that we have taken? That is summation 1 over n. That's the bn we have taken, right? And what do you know about this summation? Can someone tell me? Yeah, that's divergent. Correct. So this is divergent because we have seen it in P series test. Okay. So since summation bn is divergent, so what can we say about summation an? Therefore, by limit comparison test. Okay. So summation an, that's actually summation n equals to 1 to infinite. What is given? 1 plus n. Sorry, I think this is the last one. What is the problem here? Sine of 1 by n. Okay. So this sine of 1 by n, and this is divergent. Do you understand why is it divergent? Because summation 1 by n is divergent, and we know that the ratio of n term here and 1 by n is constant. Therefore, if one is divergent, other one will be divergent for sure. Okay, so this is how you need to apply limit comparison test.